Hello, and welcome to this video on the reactance of capacitors and inductors. To start off with, I'll be talking about capacitive reactance. In an AC circuit, since the applied voltage signal acts like a sine wave, continually changing its polarity at a rate determined by the frequency of the supply, the capacitor switches between being charged or discharged in the same way. As the capacitor charges or discharges, a current flows through it, which is restricted by the internal resistance of the capacitor, which is known as capacitive reactance, XC, measured in ohms. Unlike resistance, which has a fixed value, capacitive reactance varies with the applied frequency. As the frequency applied to the capacitor increases, its reactance decreases, and vice versa. In a purely capacitive circuit, the current leads the voltage by 90 degrees. Capacitive reactance is represented by XC and is measured in ohms, and is calculated using this formula. As an example, imagine you had this circuit. We can solve for the capacitive reactance with the equation we saw before. We know that the frequency of the circuit is 60 Hz, and we also know that the capacitance of the circuit is 100 microfarads. Subbing these two values into the formula, you will get this line, and solving, you will get 26.53 ohms. Now, with inductive reactance. Similarly to what I just explained with capacitors, an AC voltage supply across an inductor produces a phase difference between the voltage and the current waveforms. The opposition to current flow through the coil windings depends on the frequency of the waveforms as well as the inductance. This opposition to current flow is called inductive reactance. Just like capacitive reactance, it is measured in ohms and has no fixed value, as the input frequency alters it. In a purely inductive AC circuit, the current lags the voltage by 90 degrees. Now imagine having this circuit. This example is a little different because the unknown that you need to calculate is Vs. But first of all, we will need to calculate the value for resistance, or XL. The formula for this is XL is equal to 2 pi FL. Now we know that the frequency is 400 Hz and the inductance is 15 millihenries. And subbing these two values into the formula, we get this, which is equal to 37.7 ohms. Now we can solve for Vs by using Ohm's law, with the resistance equal to XL, and the current equal to 10 milliamps, which you can see in the circuit. These values into Ohm's law give you a voltage of 0.377 volts. I hope you learned a lot about the reactance of capacitors and inductors from this video. Thank you for your time.